Hi, I'm General Manager of Missoula Community Access Television. We're at the University of Montana's Adam Fieldhouse with Jerry Esme, who has run the Montana Science Fair for 14 of its 48 years. So thanks again, Jerry, for being here. I was just noticing as I went by how much paperwork there is for every exhibit. You've got on this table a set of reporting things from each kid on their exhibit.
Yes, it is somewhat paperwork, extensive. What we have finally reached this year is electronic registration through the internet. That is, the students were able to register for the fair through the internet, but we required them to send in certain hard copy documents either through the mail or through fax, and we had to collect a few here today that didn't get them into us prior to the fair. And so generally down here on the floor, we're talking about there has to be some documentation that shows that the teacher was involved with the student in deciding what the experimentation was going to be about and actually monitored that experimentation so that it was carried out in a safe manner. And we've also got a student conduct form this year. It's mainly, I call it a leverage to try to get the students to acknowledge that they do need to stay under some control down here, right, rather than being completely rowdy, and that there are certain behavioral patterns that we won't tolerate.
On the other hand, I think for kids it's a really fun experience too. I mean, there might be a lot of tempting stuff to be in this huge building, all these different places to go, and a lot of responsibility because they're supposed to stay with their exhibits during the judging process.
Yeah, 99% of the kids are, as you noted, want to be here. They want to tell about their project, explain what they did, and we have no problems with it.
Hi, we're on the floor of the Adams Fieldhouse. It's just covered with exhibits from all over the state. We've got kids from far and wide doing science experiments and being judged right this afternoon at the science fair. Let's take a look around.
My name is Kenriello. I'm working on what kind of water is best for a plant to grow in.
And what are some of the things you did?
I had to find where to get my water from. And I also had to find out what kind of bean that will grow the fast. And when you use kidney beans, it only takes 3 weeks for them to get that big. And the best kind of water if you're going to be growing plants, if you have a bird bath and it's been raining overnight, use rainwater because the rain grew 6 inches.
And here's your conclusion. Well, how long did it take you to work on your science project?
Well, we started in December and we got done on January 25th. So it took about a month to 2.
And what did you determine about polluted water and the kidney beans? Did the plants grow faster in the polluted water or slower?
Slow in the polluted water.
Oh, yeah. And what is your exhibit about?
Killing crickets.
Killing them?
Yeah.
Okay. Why? Well, I don't know. I'm just going to ask, why would you want to kill them?
To find out which chemical would kill them the quickest.
Okay. And that's your problem here. Which chemical, ammonia, rubbing alcohol, or gasoline, will put crickets to death the quickest? And what can you tell me about that?
Gasoline worked the best out of ammonia and alcohol, and
well, how many crickets did you have to test to come up with your result?
I had to do 5 crickets for each chemical.
Oh, yeah. Hi, we're talking to who's also from Lolo Middle School, and your experiment seems to have a solar panel in it. What's that all about?
Yeah, I tested different angles of a solar panel to see which one produced the most current when I had it towards the sun.
And what did you find out from your experiment?
That 70 degrees produced most current because it was flatter than the other two angles that I tested.
And how did you get into it? Like, where did you get the solar panel that you experimented with?
Solar Plexus lended me a panel for a couple of weeks, and they're nice enough to do that for me.
And did you run things off that electricity or use like a voltage meter to gauge how much it put out?
I use an OHM meter, and it just measures the flow of electricity.
I'm Shelby Katie, and I'm from Ashland, Montana. And my project is on diabetes in Native Americans, a genetic disorder or a predisposition that can be avoided by lifestyle changes. So my question was, is diabetes a genetic disorder or is it just a predisposition? And then so what I did was we tested their blood sugar. We found out that it actually was not a genetic disorder. It's just a lifestyle changes.
And having to do with diet or such?
Yeah, it's a lot with doing by diet and stuff, and how our culture sort of got lost along the way as they put us onto reservations.
And then you feel like the diet of your tribe changed on the reservation to something else.
Because we couldn't go out to get our hunt and food, to hunt for our food and pick berries anymore, because we were put onto reservations to live.
And so the healthy diet that your tribe once had was replaced, you mean, with other foods, maybe high in sugar or something like that?
Yes, it was more high in cholesterol, carbohydrates, and like that sort of stuff.
Did you enjoy undertaking your science experiment?
Yes, I really enjoyed it. It was a lot of fun because we got to, first we got to go up to my Auntie Alma Snell's house. She wrote a book, and then she's an old elder, and she taught us how to prepare old sort of foods, like foods from the past almost, sort of like.
Because you have some list of things, of foods like choke cherries and pemmican. What is that for people who may not know what pemmican is?
It's choke cherries ground up with the seeds and everything. You sit there and you grind it up, and then you add in some dry meat too. And then you add, and then we made it into little rounds, and then we let it dry for 3 days.
Well, thanks so much for sharing your experiment.
Yeah, why, thank you.
Well, I'm Bert Karlstrom, and I'm from Three Forks. And for my experiment, I tested the germination of various crops grown in southwestern Montana. And what I did was I took 50 large wheat seeds and 50 small wheat seeds and laid them out on a paper towel. I put a damp paper towel over them. I rolled it up and left it on the counter for 10 days. I repeated this with the small wheat seeds, the large barley seeds, and the small barley seeds. And then my conclusion was that the large wheat seeds grew better than the small wheat seeds, and the small barley seeds grew better than the large barley seeds.
Did you expose them to sunlight, or were they just indoor?
They were just sitting indoors. I left the plastic bag open so that they could get air, but I didn't expose them to sunlight because it was just testing the germination, and so the seed would, in a real experiment, it would have been underground where it couldn't have obtained any sunlight.
And did it take a long time to come to the conclusion?
It took 10 days, was all.
Right.
After 10 days, I unrolled the 4 packets and recorded my results.
We tested what ear protection would work the best for loud noises.
Okay, and did you use different types? Like I see cotton balls, like the traditional kind of construction workers' earplugs, and then the big headphones.
Yeah, we used 4 different types, the green earplugs and the orange earplugs, and there is a difference between the two besides color.
Oh, yeah. Oh, you want to tell me what the difference is?
Well, the shape and how it fits in the air.
Oh, yeah. And what else have you got there? It looks like you've got a volume meter or something like that.
Yeah, it's a decibel meter. It reads sound waves and how loud the sound is. And we would stick the decibel meter inside of the foam head to see what ear protection would block out the most sound.
And so you experimented, like what was the shotgun the source of the loud sound that the meter measured?
Yeah, and a backup beeper on a fire truck and an air wrench.
Oh, so you tested 3 things, gun, beeper, and the air wrench.
Yeah.
And what was your conclusion?
Well, we found out that the earmuffs work the best because they can cover the whole ear, and the larger the ear protection, the more sound waves it absorbs.
My name's Jesse Johnson. I'm here, I guess, as an honorary judge. This is my first year here at the Montana State Science Fair. I've been asked by Jerry Esme to sort of take this over. Jerry's retiring, and so this year I'm an honorary judge. Next year I'll be involved quite a bit more with a number of other things, and then I'm in charge.
What do the judges look for, do you think, when they are awarding the top awards at the fair?
They have a matrix that they complete on a piece of paper that includes things like creativity, how good the hypothesis itself is, how close the students are coming to really addressing the questions that they raise. And I think there are a number of other criterion in there that I don't remember right now. But they have a sort of a worksheet, and I think they assign students in terms of percentages. And then they're up there right now discussing who got what percentage and where and how that impacts their final decision.
Tell me, what did you do here?
We took fruits and we used a voltage meter.
We used the voltage meter to determine how many electrolytes the fruits contained, and that would make the fruits create electricity.
And which fruit did you find contained the most electricity?
The lemons had the most.
Oh, yeah. Because I can see on your chart.
Yep.
The lemon is almost way off the chart of everything.
Yeah.
The apple didn't seem to have very much electricity at all. Well, what did you think of your science project? Was it fun?
Yeah, it was.
Did you enjoy yourself?
Yeah.
All right. What is yours called? I see it's called the effect of spraying garlic plants with kochia weed extract? Kochia.
Yeah.
What is that about?
Well, basically, kochia is a weed that grows everywhere. And so I wanted to find out that if garlic was exposed to kochia, that if it would help the antimicrobial properties of garlic.
And what did you find out?
I found out that when it was exposed to the garlic, as you can see up here, that my experimental 1, which was sprayed with garlic, my experimental 2, which was sprayed with distilled water, and my kochia garlic, which was added, kochia extracts, had a greater inhibition zone than my control.
And can you think of a practical application for your experiment?
Not really.
How about yours? Yours says, is your toothbrush a biohazard? Yikes. I bet mine is. How did you conduct your experiment?
I got permission slips from all the students, and I gave them each how long they were supposed to use it. Then I collected them, and I gave them a toothbrush, and I told them to use it in a regular manner, and then I gave them a control so that I would know how much bacteria is collected in their drawer. And then I diluted them to 10 to the 4th, and I spread them, and I put them in the incubator at 37.5 degrees Celsius, and I counted the bacterial colonies on there every 72 hours.
And did you find a lot of bacterial colonies on the toothbrushes?
On this one, you can see that there was 97, an estimate of 97 on the bacteria.
And is that really high, the 97?
Yeah, for just 30 days, it's pretty high.
And is this a picture of you, measuring? It looks like there's a lot of biohazard garb being worn.
Yeah.
And then you had some help. It says mentors Lacey and Jeff explain the use of pipettes for measuring fluid. So you had some help with your project.
Yeah.
What did you think of it? Was it fun to do?
It was very fun to do.
And do you think there's a lesson to be learned about the toothbrush?
You should store it somewhere besides your bathroom, actually, because it's not the safest place to keep it. Because there's so many people go in your bathroom and bring germs with them.
And Tyler, where are you from?
I'm from Anaconda, Frederick Moodry Middle School.
Oh, yeah. So you came over just for the science fair?
Yeah.
Okay. And what do you got here? You got something called the Essential Oil of Lemon Power.
Yeah, we're just going to see if the essential oil of lemon would dissolve petrochemicals in styrofoam.
Whoa. So the idea is to break down petroleum chemicals without causing any other damage because it's kind of a natural agent or something?
Right. We're going to try to see if it will absorb the petrochemicals in a styrofoam container.
Whoa.
And see if it will harm the human body.
And what was your conclusion?
That it will dissolve, as you can see in the paper cup, it will dissolve petrochemicals and it will not harm the human body.
All right. And how long did it take you to conduct your experiment?
About 3 weeks.
Oh, yeah. And did you have help from your teachers doing it?
No.
Oh, yeah. Well, would you recommend the science fair if kids are watching and they want to do it? Do you think it's a pretty fun deal?
Oh, yeah. It's really fun to watch how you can take this styrofoam into a goo in 10 seconds.
Oh, yeah. All right. Well, thanks, Tyler. Hi, we're talking to me. She's from Lolo Middle School. And it looks like, Brittany, you were doing an experiment on home insulation. Is that right?
Yes.
What was your hypothesis when you did your experiment?
My hypothesis was that fiberglass insulation would work the best out of fiberglass, foam, wood chips, and no insulation.
And what were the conclusions?
The fiberglass insulation and the foam insulation both tied for an average drop of temperature.
And how did you conduct your experiment?
I got a large cardboard box and I lined the sides and the bottom with the type of insulation. Then I put a smaller box inside of that as a vapor barrier, and I heated a glass of water to 210 degrees Fahrenheit, stuck the glass of water in, covered the box with some more insulation, and checked the temperature of the water every 10 minutes for 130 minutes.
Oh my gosh, that's 13 times. And so the idea was to see in which material had the water lose temperature the slowest or the fastest?
Yeah, the slowest.
Oh yeah. And so if people are watching, they should know fiberglass insulation is better.
Yeah, and the foam was also, it worked with it.
Did you have a good time on your experiment?
Yeah.
We're on the second level of the Adams Fieldhouse, and this area has a lot of high school exhibits, including what looks to be like an automatic vacuum cleaner. We're talking to Corey, who's from Hobson, Montana, about his remote-controlled vacuum cleaner. And Corey, what are the principal components of the unit?
We got a scrubber, a vacuum that sucks up the dirt, and then we got the Swiffer on the back, and then we got like a car window washer that sprays the water onto the ground.
It's excellent. And I hope people can see at home that they've also incorporated a closed-circuit camera that's beaming a signal to a monitor. How long did it take you to put it together?
About 2 months.
And did you use a lot of remote control devices? Did you have to understand, I guess, a lot about remote control devices to put it together?
Yeah, we learned a lot about that last year when we did our project, and this year just kind of broadened it into a newer project and a lot more into it.
It definitely seems to have a practical application. Have people used it in any kind of cleaning context?
No, we just use it at home.
Great. Well, thanks so much for talking about it. Talking with Van Wilburton. He's one of the judges for the high school component of the fair. Van, what are some of the things that judges are looking for today?
Well, we try to look at the source of the idea, where they got the idea for the project. We, of course, are more interested in those where the students themselves have come up with the idea. How well they understand the scientific principles, or in my case, engineering principles involved. How much of the work they did themselves, how much they understand of the principles involved in what they're trying to do.
And do you feel that the science fair is a pretty good motivational component to a secondary science program?
Oh, I would imagine that it's an extremely important part of it because, you study this stuff in the laboratory or the classroom, but to actually get out and be able to do some of the work yourself and get some feedback from it, and in some cases get some reward from it, really makes it much more than just a learning experience.
I'm Lebowski from Turner. I'm Mandy Baldick, also from Turner.
Okay. And can you describe a little bit about the experiment you're presenting here today?
Basically what we did was we used the process of electrophoresis to distinguish between E. coli that was resistant to tetracycline and non-resistant to tetracycline. And it was just a simple process. We don't have any lab equipment where we're from, and all we did was order a little electrophoresis chamber out of a catalog. We didn't have any science help. We weren't in any laboratories. We just did it at school. So this is just basically what we did, and we were able to distinguish between the differences. So.
And did you find that the original hypothesis you had was borne out by the experiment, or were you surprised?
Our hypothesis was proved correct in a sense, but the only thing was our tetracycline antibiotics, we couldn't find, it killed all of our E. coli, and we didn't find any that was resistant to it, so basically we had to find differences in between our E. coli strains that we grew through our Petri dishes.
I wanted to ask, if kids are watching this at home on MCAT's Channel 7, and they wanted to get involved with a science fair, what's the easiest contact point for them to get involved with a science fair?
Well, they should talk to their teacher, their science teacher, and see if the science teacher isn't already, participating or will consider participating. We have a few projects here that come directly because the school wouldn't, sponsor them, so to speak. But generally, the science teachers around this area are participating. It's a matter of getting the student hooked up with them.
So kids, if you're watching, talk to your science teachers if you want to join this crowd here at the Montana Science Fair.
Mentioned in the field now, judges, it's 2 o'clock, so be planning your judging accordingly. Students, you got to sit down and be quiet. Judging is still occurring. Thank you. Bye.